Okay, now let's move on to learning about plots that will tell us about relationship between the data. And those will be bar plot, scatter plot, and heat map. And we're gonna go one by one. So let's first go over bar chart. So bar charts are a type of chart used to compare data across different categories. So we will look at the purpose of the bar chart, how to construct them, and how to interpret them. So what is a bar chart? So bar chart is a chart that uses bars to represent the values of a variable for different categories. The length of each bar represents the value of the variable for that category. So bar charts are commonly used to compare data across different categories and to show trends over time. How can you interpret a bar chart? So a bar chart provides a visual representation of the values of a variable for different categories. So the height of the bars provides a quick and easy way to compare the values of the variable for different categories. And some common ways to interpret a bar chart includes uh, comparison. So what we mean by comparison, you want to compare the values of the variable across different categories. Like you want to see which category has the highest value, which category has the lowest value. Trend, you want to look for trends over time. Are the values of the variable increasing or decreasing over time? And then you can look at ranking. So you can use the bar chart to rank the categories by the value of the variable. For bar chart creation, you can use Seaborn, and for this example, we'll use the data set from the US Department of Transportation that tracks flight delays. So we will set the bar chart figure size and add title. So the commands for customizing the text and size of the figure are familiar with creating a line chart. So let's look at this code and break it down one by one on the next slide. So we saw SNS bar plot. This tells the Jupyter notebook that we want to create a bar chart. And remember that SNS refers to the Seaborn package, and all of the commands that you use to create charts in this course will start with this prefix. And for x equal flight data index, this determines what to use on the horizontal axis. So in this case, we have selected the column that indexes the rows. In this case, the column containing the month, y equals flight data nk. This sets the column in the data that will be used to determine the height of each bar. In this case, we select the nk column. One important thing that you want to know is you must select the indexing column with flight data. That index, and it is not possible to use flight data month. If you use flight data month, it will return an error. It's because when we loaded the data set, the month column was used to index the rows. So we always have to use special notation to select the indexing column. Okay, we went over bar plot. Let's move on to discuss plot, uh, scatter plot. So scatter plots basically is a chart that displays the relationship between two variables, and the values of one variable are plotted on the horizontal axis, and the values of the other variables are plotted on the vertical axis. And each point on the chart represents a pair of values for the two variables. How can you interpret a scatter plot? So scatter plot provides visual representation of the relationship between two variables, and the position of each point on the chart provides information about the values of the two variables. Some common ways would be looking at relationship, strength, outliers, and correlation. So for relationship, you want to look for a relationship between the two variables, and you want to ask questions such as this: is there a pattern in the points on the chart? And for strength, you want to determine the strength of the relationship. You might want to find out whether points are tightly clustered or widely spread out. And outliers, you definitely want to look for outliers or data points that are far away from the main cluster of points. For correlation, you can use the scatter plot to calculate the correlation coefficient, which is a measure of the strength and direction of the relationship between the two variables. So how can you construct a scatter plot? So to construct a scatter plot, you can use SNS.scatterplot, and then you want to specify the values for the horizontal x-axis and the vertical y-axis. For us, for X, it would be insurance data, BMI, and the Y would be insurance data charges. So this scatter plot you get basically suggests that the body mass index, BMI, and insurance charges are positively correlated, where customers with higher BMI typically also tend to pay more in insurance costs. So this pattern makes sense since high BMI is typically associated with higher risk of chronic disease. In order to check the strength of this relationship, you might like to add a regression line, as you can see from this chart. So basically, it's a line that best fits the data. So you can do this by using the command called SNS reg plot, regression plot. Color-coded scatter plot. So we can use scatter plots to display the relationship between not only two, but three variables. And one way of doing this is by color coding the points. So for example, to understand how smoking affects the relationship between BMI and insurance costs, we can color code the points by smoker and plot the other two columns, BMI and charges on the axis. So this scatter plot shows that while non-smokers tend to pay slightly more with increasing BMI, smokers pay much more. In order to emphasize this fact, we can use SNS LM plot command to add two regression lines corresponding to smokers and non-smokers. So we can do lmplot and then specify x and y, and we can set Q as smoker and provide data. And you will, after you make this, you will see that the regression line for smokers has a much steeper slope relative to the line for non-smokers. One thing you want to be mindful is instead of setting X as insurance data BMI, we selected BMI column. Similarly, Y equal charges and Q smokers also only contain the names of columns. So just keep in mind when you're using lmplot. Finally, there is one more scatter plot that you will learn about that might look slightly different from how you're used to seeing scatter plots. So usually we use scatter plots to highlight the relationship between two continuous variables, like BMI and charges as you saw. We can adapt the design of the scatter plot to feature a categorical variable, which is categorical variable that has yes and no, smoker, on one of the main axes. So this plot type is called categorical scatter plot, and you can build it with the SNS swarm plot command. So what can you observe from this plot? Among other things, this plot shows us that on average, non-smokers are charged less than smokers, and the customers who pay the most are smokers, whereas the customers who pay the least are non-smokers. Okay, so we looked at line plot and bar plot and scatter plot. So now let's move on to heat map. So what is a heat map? Basically, heat map is a chart that uses color to represent the data in a matrix format. So the rows and columns of the matrix represent different categories, and the color of each cell represents the value of the data. So heat maps are commonly used to visualize large amounts of data and to identify patterns and trends in the data. How can you interpret a heat map? So you can see that the color of each cell provides a quick and easy way to compare the values of the data across different categories. So you want to look at comparison, trend, and clustering to interpret heat map. So for comparison, you want to compare the values of the data across different categories, and you might want to see which category has the highest value and which category has the lowest value. And for trend, you want to look for patterns and trends in the data, and you'll see, are there any area of the heat map that are consistently high or consistently low? And lastly, you want to look for areas of the heat map where the colors are similar. So these areas represent clusters of similar values in data. So how can you construct a heat map? You can, in order to construct a heat map, you want to follow these steps. First is determine the data. You want to determine the data that we want to visualize. And you want to choose a scale for the color gradient that is appropriate for the range of values in the data set. and you can create a matrix with rows and columns that represent the categories of the data and color the cell. In order to do that, you can use a Seaborn heat map and provide data and just set annotation to be true. Then what happened is when you set annotation true and provide flight data, it will show average arrival delay for each airline by month. And the darker colors show negative value, and the lighter color shows positive value. So 3 main components you want to remember is SNS heat map. This tells the Jupyter Notebook that we want to create a heat map. Data is flight data. This tells Notebook to use all the entries of flight data to create the heat map. And annotation true. This ensures that values of each cell appears on the chart. So if we leave this out, or if we set this to be false, then the numbers of each cell will be removed. Can you detect any patterns by looking at this heat map? If you look closely, the month toward the end of the year appears relatively dark for all airlines. This can suggest that airlines are better on average at keeping schedule during these months. So here's a summary for relationship. We've looked at many different chart types to understand relationship, and 3 of them are bar charts, scatter plots, and heat map. And in scatter plot, we not only looked at scatter plot, which shows the relationship between 2 continuous variables. We also learned how to include a regression line in the scatter plot by calling reg plot. And if we wanted to draw multiple regression lines, if your scatter plot contains multiple color-coded groups, then you can use lnplot. And we also learned about categorical scatter plot, which shows the relationship between a continuous variable and a categorical variable. To do that, we use sns.swarmplot. Okay, we went over line plots for trends and relationship.